Welcome dear students in the class. Today we will discuss the plane in the three-dimensional coordinate geometry. So first of all, what is plane? The surface which consists of all the points on the straight line joining any two points on it is called a plane. It means what is plane? If we take 2 points on any surface and join them by a straight line, then all the points lying on the straight line, if lies on that surface, then that surface will call a plane. General equation of plane. The general equation of first degree in three variables x, y, z means ax plus by plus cz plus d is equal to 0 represents a plane. We have to show that this general equation of first degree represents a plane. So let take 2 points P x1 y1 z1 and Q x2 y2 z2 on the surface ax plus by plus cz plus d is equal to 0. And let P be a general point on the line joining the point P and Q, which divides the line PQ in ratio lambda and 1. Then coordinate of P are lambda x2 plus x1 upon 1 plus lambda, lambda y2 plus y1 upon 1 plus lambda, lambda z2 plus z1 upon 1 plus lambda. Putting this general equation in the equation of curve, we get this point satisfied in the curve. We will show this. So point P x1 y1 z1 and Q x2 y2 z2 lies on the surface, so they will satisfy the equation of that surface. It means ax1 plus by1 plus cz1 plus d1 is equal to d is equal to 0, ax2 plus by2 plus cz2 plus d is equal to 0. Multiplying 2 and add in 1 and dividing by 1 plus lambda, we will get the equation which shows that this general point lies on the surface ax plus by plus cz plus d is equal to 0. But this general point is a general point. If it's lie on the surface, then whole lie lies on the surface ax plus by plus cz plus d is equal to 0. It means ax plus by plus cz plus d is equal to 0 represents a plane. It is called a general equation of plane. Now equation of coordinate planes. In three-dimensional coordinate geometry, here we are showing in this paper that this is x-axis, this is y-axis, this is z-axis. The plane containing the x-axis and y-axis is called xy plane. The plane containing the y-axis and z-axis is called yz plane, and the plane containing the x-axis and z-axis is called xz plane. They are called coordinate planes. Coordinate planes are xy plane, yz plane, and zx plane. Now, at xy plane, z is equal to 0. So, the equation of xy plane is z is equal to 0. The equation of yz plane is x is equal to 0. And the equation of the plane xz plane is y is equal to 0. These are the equations of coordinate planes. Means xy plane is equal to z is equal to 0. Equation of yz plane is equal to x is equal to 0. Equation of xz plane is y is equal to 0. Now equation of planes parallel to these coordinate planes is simply the equation of the plane parallel to the xy plane is z is equal to c. The equation of the plane parallel to the yz plane is x is equal to c, and the equation of the plane parallel to the xz plane is y is equal to c. Now we will find the equation of any plane passing through a given point. Suppose P is a point whose coordinates are alpha, beta, gamma, and we have to find out the equation of any plane passing through the point alpha, beta, gamma. So assume that let the equation of the plane is ax plus by plus cz plus d is equal to 0. This plane passes through the point alpha, beta, gamma, so it becomes a alpha plus b beta plus c gamma plus d is equal to 0. It is the second equation. Subtracting these, we will get a x minus alpha plus b by minus beta plus c z minus gamma is equal to 0. It is the required equation of the plane passing through the point alpha, beta, gamma. So what you know? Equation of any plane passing through the point alpha, beta, gamma is what? A x minus alpha plus b by minus beta plus c z minus gamma is equal to 0. Now we have to find out the equation of plane, what it indicates. If the equation of the plane is ax plus by plus cz plus d is equal to 0, then a, b, c are the normals, direction ratio of the normal to the plane. What it means, clearly see that if this copy you are seeing is a plane, then any line perpendicular to this paper, this is normal to the plane. So if this plane is ax plus by plus cz plus d is equal to 0, then a, b, c are the direction ratio of this normal. Clear? This is a very important thing, that if the equation of plane is ax plus by plus cz plus d is equal to 0, then what ABC represents? ABC represents the direction ratio of the normal to the plane. It is very important. We will use this fact throughout the studying plane and straight line. For example, suppose we have to find out the equation of the plane parallel to the x-axis. Suppose the equation of the plane in general form is ax plus by plus cz plus d is equal to 0. The direction ratio of the normal of this plane is ABC. Now the direction ratio of x-axis is 1, 0, 0. Since x-axis is parallel to the plane, so it will be perpendicular to the normal to the plane. So the angle between x-axis and the normal of the plane will be 90. Applying the condition of perpendicularity means a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Here we get a is equal to 0. So putting a is equal to 0 in the plane, ax plus by plus cz plus d is equal to 0, we get the equation of the plane parallel to the x-axis is by plus cz plus d is equal to 0. If this plane also passes through the origin, then its equations becomes by plus cz is equal to 0. Similarly, we can find the equation of the plane parallel to the y-axis is given by ax plus cz plus d is equal to 0. Similarly, the equation of the plane parallel to the z-axis is given by ax plus by plus d is equal to 0. equation of the plane in intersect form. The equation of the plane which cuts off intersects on the coordinate axis is known as intercept form of the plane. Assume that ABC be the intercept made by the plane on the coordinate axis. Let the equation of the plane is given by capital AX plus capital BY plus capital CZ plus capital D is equal to 0. Only notations are changing. If this plane cuts the x-axis, at x-axis, clearly we know that y is equal to 0 and z is equal to 0. So we get capital A is equal to capital D upon A. Similarly, when plane A cuts the y-axis, we get capital B is equal to minus D upon small b. Similarly, when this plane cuts the z-axis, means at z-axis x is equal to 0, y is equal to 0. Putting this, we get capital C is equal to minus D upon C. Putting the values of capital A, capital B, capital C in the plane, AX plus BY plus CZ plus D is equal to 0, where ABC are in capitals. We get the required equation of the plane in the intersect form. It may be represented as x upon A plus y upon B plus z upon C is equal to 1. Next, we have to find out the equation of the plane in the normal form. When the equation of a plane represented in the form of P and element, it is called the equation of plane in normal form, where P represents the length of the perpendicular from the origin to the plane and LMN are the direction cosines of this norm. Or in this case, we get the equation of the plane becomes Lx plus My plus Nz is equal to P. Means, clear? Equation of the plane in the normal form is Lx plus My plus Nz is equal to P, where P is the length of the perpendicular from the origin to the plane and LMN are the direction cosine of the normal to the plane. Now, we will tell you how to find out the equation of a plane passing through the three given points. Means we have to find out the equation of a plane passing through three given points. These given points are A, whose coordinates are x1, y1, z1, B, whose coordinates are x2, y2, z2, and C, whose coordinates are x3, y3, z3. Assume that the equation of the plane in general form is ax plus by plus cz plus d is equal to 0. Since this plane passes through these points ABC, therefore the coordinates of A, B and C will satisfy the equation of the plane. Putting these 3 points in the equation of plane, we get 3 equations. Ax1 plus by1 plus cz1 plus d is equal to 0. Ax2 plus by2 plus cz2 plus d is equal to 0. And Ax3 plus by3 plus cz3 is equal to 0. Including the equation of plane, we have assumed we get these 4 equations. So here we get 4 equations whose right hand side are 0. And 4 constants A, B, C and D. Therefore, eliminating A, B, C and D from these 4 equations, we get a determinant of 4 by 4 whose first column is x, x1, x2, x3. Second column is y, y1, y2, y3. Third column is z, z1, z2, z3. And fourth column is 1, 1, 1. This determinant is equal to 0. This is the required equation of the plane passing through 3 given points. Clear? Now next we will tell you about the angle between two planes. The angle between two planes is defined as the angle between their normals. Means if the two planes we have given a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0, then direction ratio of the normal of the first plane is a1 b1 c1. Direction ratio of the normal to the plane second is a2 b2 c2. Then the angle between these two normals is defined as the angle between two planes. So angle between two planes is equal to, if the angle is theta, then cos theta is given by a1 a2 plus b1 b2 plus c1 c2 upon under root a1 square plus b1 square plus c1 square under root a2 square plus b2 square plus c2 square. If the angle between these two planes is 90, clearly then theta is equal to 90, so cos theta is equal to 0. It means a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This is the condition of perpendicularity of two planes. So what is the condition of perpendicularity of two planes? a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Similarly, the condition of parallelism of these two given planes is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Note that suppose you have given a plane ax plus by plus cz plus d is equal to 0, and you have to find out the equation of the plane parallel to this plane. Simply you change the constant to only d. Means equation of the plane parallel to the plane ax plus by plus cz plus d is equal to 0 is given by ax plus by plus cz plus lambda is equal to 0, where lambda can be found by the conditions given in the problem. We will simply discuss here one simple problem. First problem is find the equation of the plane through the point 1, 3, 2 and parallel to the plane 3x minus 2y plus 2z plus 33 is equal to 0. So solution. We have told you that equation of any plane parallel to the plane ax plus by plus cz plus d is equal to 0 is given by ax plus by plus cz plus lambda is equal to 0. So equation of the plane parallel to the plane 3x minus 2y plus 2z plus 33 is equal to 0 is given by 3x minus 2y plus 2z plus lambda is equal to 0. Now we have to find out the value of lambda. Clearly it is given that this plane is passing through the point 1, 3, 2. So put the point 1, 3, 2 in this equation. We will get the lambda value of lambda. It comes out to be minus 1. See here. And put the value of lambda. We get the required plane. So the required equation of the plane we get is 3x minus 2y plus 2z minus 1 is equal to 0. Again, next problem. Find the equation of the plane through the point 1, 2, 3 perpendicular to the plane x plus 2y plus 3z is equal to 1 and parallel to the z-axis. Very important problem. See here, equation of the plane passing through the point alpha, beta, gamma is given by a x minus alpha plus b by minus beta plus c z minus gamma is equal to 0. Using this equation of any plane passing through the point 1, 2, 3 is given by a x minus 1 plus b by minus 2 plus c z minus 3 is equal to 0 here, equation A. Now it is given that this plane is perpendicular to the plane x plus 2y plus 3z is equal to 1. So applying the condition of perpendicularity means a1 a2 plus b1 b2 plus c1 c2 is equal to 0. We get the equation a plus 2b plus 3c is equal to 0. Now it is given that this plane A is also parallel to the z-axis. See here, if the plane is parallel to the z-axis means z-axis is parallel to the plane, so z-axis is perpendicular to the normal to the plane. Again applying the condition of perpendicularity, direction ratio of z-axis is 0, 0, 1. Applying the condition of perpendicularity, we get c is equal to 0. So putting c is equal to 0, we have a plus 2b is equal to 0. Now write ab in terms of k and putting the value of abc in the equation of plane, we get the required equation of plane is comes out to be 2x minus y is equal to 0. Clear? Any doubt? Any problem? So today it is sufficient. Be careful, stay at home, obey the law of the governments to save yourself from this coronavirus and work hard for the examination and live healthy. Thank you.